Hello friends, welcome back to the channel. My name is Desmond, a final year computer science student from University of Malaya. In this video, we will talk about the Lab 1 and we will try our best to solve it. So before this video, remember that you need to watch the previous video, which is about the preliminaries that you need to know before getting into this video. So now, without further ado, let's get started. So the task is to fill in this truth table. For the output, we should either fill in 1 or zeros. So that just depends on the output that we get from our circuit board that we are going to build. So in this video, we are just going to focus on this table and this chip. So for the other chips, you could try to attempt on your own, but I believe that once you know how to do the experiment for this chip, you could go on and complete the other chips. Like I said just now, we are going to focus on this chip, 74LS00. So this is the configuration of the chip. If we zoom in, there are 14 pins in total. So the pin starts from here, usually the left of this notch. So this notch here helps us to identify the orientation of the chips, and usually we will start from here, and this will be 1, 2, 3, 4, 5, 6, 7, and so on until 14. So first, let's look at this VCC pin. So this VCC, like its name states, it should be connected to VCC, and for this ground, it should be connected to ground. All right, and if you observe, there are actually a few combinations over here that you could group them together. So the first group, it's 1A, 1B, and 1Y. Second group, 2A, 2B, and 2Y. Third group, 3A, 3B, and 3Y. Then 4A, 4B, and 4Y. So what does this mean? What does A, B, and Y means? So A and B are actually the inputs. So you could say A, maybe you say it's input 1, and B is input 2. Then the Y would be the output. So how does this work? Right, let's assume since we do not know what's happening inside here, let's assume that this A, B, and Y, I mean this chip is a combination of AND gates, let's say AND gates. So if I input 1 over here and 1 over here, the output should be 1 because we assume that this is an AND gate. Okay, so if I put 0 and I put 1, then the output should be 0. And if I put 1 at the input and 0 at the output, then the output should also be 0. If I put both zeros, then the output should be 0. So you could ask, maybe you want to know how do I specify 1 and zeros on the circuit. So 1, we say that it's VCC, and 0, it's connecting to ground. So if I connect the input to VCC, let me use a different color, it's getting messy. Red, let's say. So if I connect 1A to VCC and 1B to ground, then the output should be a 0, which we can verify by connecting it to some light bulb or LED that connects to ground. Okay, so if I connect the 1B to VCC, however, so both 1A or 1B are from the VCC, then the output should be 1, which will light up the light bulb or LED. So this is how you're going to connect the wires, and you could think of the chips right here as a connection. Let me zoom in. So let's say this would be an AND gate that get connected to here. Okay, so there are actually many gates inside every of these component. Okay, so this would be this is just an assumption. We just assume that this is an AND gate. So for 1B as well, for the 2A, 2B, and 2Y as well, we can see, we can imagine this kind of configuration inside the chips. Okay, so the same goes for 3 and 4. So this chip is actually a group of logic gates. So we have 4 logic gates over here, which we don't know the exact logic gate that we are dealing with. So that's the purpose of this experiment. Try to guess the logic gate by checking the output. So this is how you are going to make the connection. So like I said just now, VCC should be connected to VCC, ground should be connected to ground, and then we can have 2 types of input over here. Okay, so it can be, so these are the inputs that we can change. We can either connect them to VCC or ground. Same goes to this one. We can either connect them to VCC or ground to simulate the input 1 and 0s. So remember that VCC stands for 1 and ground stands for 0. So if we want 2 1s over here, then we connect both of it to VCC. If we want both 0s, we can change these to ground. Alright. And then for the output, we are going to connect it to the LED. Alright, and why we connect it to the positive terminal is because ground is the negative terminal. So we need to connect the ground to the negative terminal through a resistor. So the resistor, the importance of this resistor is to lower the current that flows through it by increasing the resistance of the circuit. Right, so that we don't burn out this LED. By changing the inputs, the A and B, according to this table, then you could have an output. So if I put A and B over to ground and I get a 0, sorry, if I put A and B to the ground and the light bulb does not light up, then I put it as 0. But before that, we need to know how to connect them on the breadboard. So this is components on the breadboard. Note that I have put the chip over here. So the chip, usually we put it at the middle, and every leg is connected to the holes on the breadboard. Okay, so like so, and I also put a resistor over here, which connects this to this, and I have also put a LED over here for the output. And to connect this, let me get a pen. We need to put the VCC. We usually would connect it over here. And for the ground, let me pick a different color. And for the ground, we would connect it to the blue line over here. Okay. Remember that this whole line is connected on the breadboard, and this whole line is connected on the breadboard. And for this, it is connected vertically. So these rows are connected, and this row are connected. So in order to connect the VCC terminal of the chip, you just have to drag a line over here to here. Okay, so the current would flow this way because this is actually connected. All right, and for the ground, this one, we would use a black color and connect it from here to the blue line. All right, so now the chip is powered up. We need to make the remaining connections. So let's use this part, 3A, 3B, and 3Y, because it's more closer to our LED. So for 3A and 3B, let's try to connect them to the ground first. The ground, then ground. So this would simulate 0, 0, okay? And for the output Y, we are going to connect it to the positive terminal of the LED, and then the negative terminal of the LED should be connected to the resistor, and the resistor would connect to the ground. So this is how you make a full connection based on this, right? So this is the connections that's made on the circuit board, and if we have connected it successfully, we should get a result. So either the LED would light out or no. So if the LED light out, we will put a 1 over here at the output. If not, then we will put a 0. So you could try with your own circuit board, try to implement this circuit and see what output you get. Okay, so this is the actual output that you should get from the circuit just now. So if you put in 0 and 0, you should get back 1, which means that the LED is light up. If you put 0, 1, you should get back a 1 as well. 1, 0, get back a 1, and 1, 1, you would get back a 0. So if you remember from the preliminaries, this gate is actually a NAND gate. Oops. NAND gate. Okay, so it is the inversion of the AND gate, and to validate your answers, you could Google the name of the chip, and then you could see that the gates shown here are NAND gates. Alright, so it's a pretty straightforward and simple experiment. You should now be able to complete the other chips as well. So thank you so much for watching this video. I hope that this is helpful to you. If you think it's helpful, remember to subscribe, like, and comment on this video, and also share it with your friends. And if you'd like to buy me a coffee, you could do that as well. Just go to buymeacoffee.com/dio. And thank you so much for watching. See you guys in the next video.